All right. The next session is a next generation of OpenEdge. So I think, what the folks have been saying, there's a lot of innovation coming up. So Nokia partnering with ASUS, they're taking the latest technologies, packaging it up into new systems, and that's the conversation you're going to have, right? All right. Cheers.
All right, so we'll go ahead and start. So again, my name is John Kaczala. I'm with Nokia. I run the Edge project under OCP. I have with me today a partner of ours.
Morning, this is Ali Irani. I'm with ASUS. I'm a sales director here in North America.
Great, so Ali and I are going to kind of walk you through some of the new things that we're doing with the sled design. So we've been working closely with ASUS to jointly develop this new generation of the 1U and 2U variants for the chassis. And one of the goals is to bring in the latest generation of technology that's happening in the Intel world. And one of the things that we've also seen driving this as something that goes beyond, when I talked about in the previous discussion, these new types of applications. So the original thinking was that the workloads would have just been sort of disaggregated RAM, but as we see, adding new types of capabilities such as AI into this space starts to drive additional resource requirements into the system. So the contribution that we're putting together highlights kind of what we've been doing with the 3U and 2U chassis, the OpenEdge RMC, the PSUs, and the OpenEdge sleds. So some of the main enhancements in this generation are the introduction of the support for PCIe Gen 5, DDR5 technologies, and the addition of new CPU, the new Intel CPU generation. These improvements bring additional improvements both in performance and capacity as well as in reduced power for some of these applications. So the new server technology brings in the fourth generation Intel Xeon Scalable processor support, increasing the memory speed from DDR4 to DDR5. Also opens up PCIe from Gen 4 to Gen 5, and increasing the number of PCIe lanes from 64 to 80. And it has an enhanced instruction set provided by this new generation. From the 2U server perspective, this enables higher processor TDP and performance, and it gives us 3 PCI slots for accelerators. So, what we're working with is a level 1 accelerator, and we can now bring in things like, a full-sized, say, NVIDIA GPU, for example, into this as well. The server supports a full PCIe 16 Gen 5 connectivity to each PCI slot. And computing performance increases compared to what we had, while at the same time maintaining kind of the same cooling power requirements. So some of the benefits for the edge use case. So as you can see here on the performance side, we get quite an improvement from power capacity and then sort of the capacity performance scenario. So these new processor architectures then are allowing us to really meet the needs of the requirements that we have in this limited environment while being open enough that we can start to add these new types of applications. And so with that, I'll turn it over to Ali. He can talk a little bit about some of the interesting things that were done to make the actual mechanics of the solution much more modular and serviceable.
Yeah, thank you, John. So we've been working with Nokia on the previous release of this product, which was Ice Lake, and now transitioning to Sapphire Rapids. And we realized there's going to be a lot of these servers in the network, and they're a critical piece of the network, so they must be easily serviced. So all the interfaces off the front, there is no tools required to replace any of the major components. They're all modular design. The fan module, SSD module, riser assembly, M.2, they can be easily replaced. Also, we realized that there are different environments in the field where you may need rear to front or front to rear airflow. So this is a flexible fan module design allowing for the different airflow configurations. Yeah, so just a quick overview of the 1U sled. So you can have up to 5 of these sleds in the chassis, and each sled has their own power button, USB 3.2, mini display port, reset button, and there is 2 expansion slots. One is a OCP version 3, the other one is a PCIe Gen 5 by 16, full height, half length module. We also decided to go with E1.S storage because they're hot swappable and very energy efficient. And you can see in the rear of the chassis the 4 fan modules and the power and signal connectors. The 2U sled allows for more flexibility in expansion. So similar design in terms of the interfaces, except you have an additional 2 PCIe by 16 full height, full length modules that you can add into this sled. Also, you have an expansion of 6 E1.S NVMe hot swappable storage drives. Same design for the fan, front to rear and rear to front. Here's the product information. You can find it both on Nokia and ASUS website, also on the OCP marketplace. So in conclusion, Nokia and ASUS together, we've jointly developed a new generation of 1U and 2U variants of the OpenEdge server sleds, featuring support for 4th generation of Intel Xeon Scalable processor.
Yeah, and as we talked about, it's bringing in the latest generation of Intel technology, so we get the enhanced instruction set. PCIe is much improved. The 2U Edge servant variant with 3 slots. So that starts to open up the ability to add different types of accelerators, and so that's something that Ollie and I were talking about last night about some of the interesting stuff that we can start to do with this. And it really enables for us a significant performance improvement with things that we want to do with Cloud RAN, Edge RAN, and these types of things. So for a call to action, again, I offer you to join us both on the Edge and on the telco OCP project initiatives around the phone calls and mailing lists. From what our plan is to have the specifications ready. They're going through some final review internally, and they were hoping, I believe, to have them up there today, if I'm not mistaken. The server will be in the marketplace by the end of 2023. And again, the project wiki and the mailing list are included in the materials. And I thank you for your attention. And do we have any questions?
Yeah, let's. Okay. Okay, go for it. You.
Yeah, I just have one question. Do you specify the type of E1.S that you want to use in terms of thickness and in terms of cooling and heat spreaders and all that kind of stuff?
Yeah, we qualify different E1.S modules from different OEMs and at different capacity. So I think E1.S can go up to very high capacity. So it depends on what the customers are looking for in the field.
Okay, so there's no specific call out for like a mechanical form factor 5.9.
No, it's a standard. Yeah.
Yeah. Well, there's different heat.
Okay, I realize the length. So there is a limit to the length of the E1.S module.
Yeah. Okay. Thank you.
Yeah. Yeah, you can find those specifications on the website.
Question over here. Yes, thank you, John Alley. Very good presentations. One of the themes I saw across it is talking a lot about expandability and things like that. And you're highlighting a lot of things around telco. I was just wondering, could you just touch briefly what sort of things you guys are looking at? Because one of the complexities, of course, of telco, especially with the VDU, is synchronization and clocking. And how do you handle some of those challenges within the server box itself to do some of that clock distribution to allow that scalability to the different cards?
Yeah, so there's several options there. I wish I would have put that in there, but you know the accelerated card platforms have that capability also with the front haul gateway. You know, so there are several different ways to go about that, the clocking. I can't recall off the top of my head, but there's about 4 or 5 different options there. Do you have any other questions?
Any other questions? Okay, thank you.
Thank you very much.
Thank you.